Hello everyone. So today I am doing class for class 10. So today's topic is also geometry. That is, in this case we will do theorems related to angles in a circle. So today we are doing theorems related to angles in a circle. So now, what is meant by angles subtended at the center and at any point on the circle? Okay, what do you mean by angles subtended at the center and at any point on the circle by an arc of a circle? So first of all, in order to do theorems related to angles in a circle, you should know about the angles subtended at the center by an arc of a circle. So before that, you should know what is meant by arc of a circle, right? So this is a circle. So this is a circle. You take any point, any 2 points on the circle AB, and suppose this point is K. So now this AKB. So let us write this AKB here. AKB. So now again I am drawing this portion AKB here. So this AKB is known as an arc of this circle. This AKB is known as an arc of a circle. Just say it is an arc of a circle, right? So in this case, AKB is an arc of a circle. So now, what is meant by angle subtended at the center by an arc of a circle? Suppose this is the center of the circle, that is O, right? You join OA and you join OB. This angle AOB is known as the angle subtended at the center O of the circle by an arc AKB. यो arc AKB ले angle AOB बनाउँदैछ at the center of the circle. At the center of the circle, this arc AKB is making an angle AOB at the center O of the circle, right? So यसमा यो जुन चाहिँ angle AOB छ, यो angle AOB लाई चाहिँ के भनिन्छ? Angle AOB is the angle subtended at the center O of the circle by an arc AKB. Is that clear now? Now, let us discuss about angle subtended at any point on the circle by an arc of a circle. Okay? So now, again draw a circle. Again you draw a circle. Okay? So now let us take these 2 points AB, and AKB is an arc of a circle. Okay? This AKB is an arc of a circle. Okay? This is one part of the circle. This is another part of the circle. Suppose you take any point C here. You take any point C on the remaining part of the circle. AKB is a part of the circle, and this ACB is the remaining part of the circle. Okay? यहाँ मैले के भन्नु खोजेको भन्दाखेरि AKB एउटा part of a circle भयो. यो ACB चाहिँ के भयो? Remaining part of the circle. So let us take C point on the remaining part of the circle, or on the circle. Okay? So now you join A and C, and you join C and B. So this angle ACB is the angle at the remaining part of the circle subtended by the arc AKB. So यो ACB लाई चाहिँ हामी के भन्छ भने, this angle ACB is the angle at the remaining part of the circle subtended by the arc AKB, or angle ACB is the angle subtended at any point on the circle by an arc AKB of the circle. Is that clear? त यो एंगल एसीबी लाई चाहिँ हामी के भन्छ भने एंगल एसीबी इज द एंगल subtended at the remaining part of the circle subtended by the arc AKB. तो यो चाहिँ भयो concept of angles subtended at the center and at any point on the circle by an arc of a circle. Is that clear? Now we will do theorems related to angles in a circle now. Okay? So now, today we are doing theorems related to angles in a circle. So let us do theorem number 3. Okay. So now, in the last online class, we did 2 theorems, theorem 1 and theorem 2. So this is the continuous theorem, that is theorem number 3. Okay. The question is, prove that the angle formed at the center of a circle by an arc is double of the angle formed by the same arc at any point on the circle. Okay, in this case you have to prove that the angle subtended at the center of a circle by an arc is twice the angle subtended by the same arc at any point on the remaining part of the circle. That means let us draw the figure, then I will explain you. So suppose this is a circle, right? तर मैले अस्ति नै भने तिमीले सर्कल बनाउँदा चाहिँ you have to use compass and pencil, right? This is a circle. त यो चाहिँ के भयो सर्कलको सेन्टर हो. Let us take any 2 points on this circle, that is AB, and this AKB is an arc of a circle. So what is AKB here? AKB is an arc of a circle. Okay? So join OA and join OB. So what is this AOB? So AOB is an angle subtended at the center O of the circle by an arc AKB. Is that clear now? Now you have to draw the angle at the remaining part of the circle. So you take any point C. This AKB is an arc of a circle, and this C point is taken on the remaining part of the circle. This AKB is a part of the circle, isn't it? So ACB is the remaining part of the circle, right? So let us take any point C on the remaining part of the circle. So here also let us join this AC and this CB. Is that clear now? So this O is here. This point is O. So let us draw it here. O is the center of the circle, right? So now, what is ACB here? ACB is an angle subtended by the same arc AKB at the remaining part of the circle. Okay? Now in this case, you have to prove that this angle AOB is double the angle ACB. That is angle ACB at the remaining part of the circle. That is, you have to prove that the angle formed at the center of the circle, that is angle AOB, by an arc AKB is double. Double means twice of the angle formed by the same arc at any point of the circle. So which is the circle, which is the angle at any point of the circle? That is angle ACB is the angle at the remaining part of the circle. That is, you have to prove that angle AOB is equal to twice angle ACB. Okay? That is, you have to prove that the angle subtended at the center O of the circle is twice the angle subtended at the remaining part of the circle, that is angle ACB. Is that clear to all of you? Now let us prove it. Okay? Now first of all you have to write down the given. Your given is, what is given here? Angle AOB is the angle at the center O at the center O of the circle. Angle AOB is the angle at the center of the circle, subtended by the arc AKB. Subtended by the arc AKB. Again, what is angle ACB? Angle ACB is the angle at the remaining part of the circle or on the circle which is subtended by the same arc AKB. So write down, angle ACB is the angle at any point C on the circle subtended by the same arc AKB. Right? So now, to prove, so what is to be proved here? You have to prove that the angle subtended at the center O of the circle by an arc AKB is twice the angle that is subtended at the remaining part of the circle by the same arc AKB. That is, you have to prove that angle AOB is equal to twice angle ACB. Now you should prove angle AOB is equal to twice angle ACB. Okay, now we will prove it. Now you have to do the construction part here. Now you have to do the construction part. Now in this case, let us join O and C. Let us join this O and C and let us produce it up to D. Let us join C and O and produce it up to the point D. Right? So construction, O comma C are joined. O comma C हामीले join गर्यौं and produced it up to the point D. Up to the point D. O comma C are joined and produced it up to the point D. Is that clear now? Now we'll do the proof part now. अब हामी प्रमाण गर्छौं angle AOB is equal to twice angle ACB. त कसरी प्रमाण गर्छौं भन्दाखेरि, now this is a triangle OAC. यो OAC एउटा ट्रायंगल भयो हैन? त यो ट्रायंगल OAC मा यो दुईटा साइड पनि इक्वल भयो. कसरी इक्वल भयो भन्दाखेरि, these are the radii of the same circle. OA and OC are the radii of the same circle. That is, OA is equal to OC. So, यो दुईटा side equal हुने बित्तिकै यो triangle OCA is an isosceles triangle. You know the meaning of isosceles triangle. A triangle is known as the isosceles triangle if two of its sides are equal, right? So, in this case, OA is equal to OC. If this side OA is equal to OC, then these two angles are also equal. You know that, isn't it? If a triangle is an isosceles triangle, and in this case OA is equal to OC, so these two angles are also equal. That is, angle OCA is equal to angle OAC, right? So in triangle OAC, OA is equal to OC, right? In triangle OAC, OA is equal to OC. If OA is equal to OC, then what can I write? angle OAC is equal to angle OCA. Is that clear? The यो triangle OAC मा यो OA is equal to OC भएको कारणले गर्दाखेरि यो दुईटा एंगल पनि के हुन्छ रे इक्वल हुन्छ. That is angle OAC is equal to angle OCA. फेरि अर्को ट्रायंगल हेरौं. In triangle OBC, in this case also this OB is equal to OC, isn't it? Being the radii of the same circle, right? That is OB is equal to OC now. Now in this case also these two angles are equal because OB is equal to OC. This is an isosceles triangle. Therefore angle OBC, that is angle OBC is equal to angle OCB. Is that clear now? So now what will you do now? Now this angle AOD, this angle AOD is the external angle. So this is a triangle, OAC is a triangle, and this AOD is the external angle. So now you know that this external angle AOD is equal to sum of the two interior opposite angle. यो दुईटा एंगल चाहिँ ट्रायंगल भित्र भएको कारणले गर्दा चाहिँ यसलाई हामी इंटरनल एंगल भनेर भन्छौं. यो जुन चाहिँ एंगल OAC र एंगल OCA छ यो चाहिँ ट्रायंगल भित्र भएको कारणले गर्दा चाहिँ हामीले त्यसलाई के भन्छौं इंटरनल एंगल्स भनेर भन्छौं. तर यो एंगल AOD चाहिँ ट्रायंगल को बाहिर भएको कारणले गर्दा चाहिँ त्यसलाई हामी के भन्छौं एक्सटर्नल एंगल्स भनेर भन्छौं. त तिमीले सायद क्लास 7-8 मा एउटा थ्योरम गर्छौं. त्यो थ्योरम चाहिँ के भन्दाखेरि दिस एक्सटीरियर एंगल AOD यो बाहिर भएको कारणले गर्दा त्यसलाई के भन्छ एक्सटीरियर एंगल. दिस एक्सटीरियर एंगल AOD is equal to sum of the interior two opposite angles. Sum of the two interior opposite angles भनेको एंगल OAD र एंगल OCA हो. तो यो एंगल OAC र एंगल OCA को समेसन चाहिँ इज इक्वल टु के हुन्छ एक्सटीरियर एंगल AOD. So here you have to write exterior angle AOD is equal to sum of the interior two opposite angles. भन्नुको मतलब के हो एंगल OCA plus angle OAC. Angle OCA plus angle OAC. Is that clear now? Similarly on the other side of CD, what can you say? We can say that this angle BOD is the exterior angle, and since in this triangle OBC, this angle OBC and angle OCB are the interior angles. Since angle BOD is the angle outside the triangle, so this is known as exterior angle BOD. So in this case also, exterior angle BOD is equal to sum of the interior two opposite angles, right? So again, exterior angle, that is angle BOD is equal to exterior angle BOD is equal to what can you write? Angle OCB plus angle OBC. Is that clear? Now let us add them. Now we can add it, right? So therefore, if you add it, the left hand side becomes angle AOD plus angle BOD is equal to, on the right hand side also you can add them, angle OCA plus angle OAC plus angle OCB. Let us write it here. This is the continuation part. As there is no space there, let us write it in the next step, right? So angle OBC. This is angle OBC. Is that clear? Or now, what is angle AOD plus angle BOD? look at the blackboard. Angle AOD यो angle भयो अनि angle BOD चाहिँ यो angle भयो नि यो दुईटा angle जोड्दा कति भयो त angle AOB right angle AOD र angle BOD जोड्दा फेरि के भयो angle AOB so let us write here angle AOB which is equal to now on the right hand side now here angle OCA so अलिक तलबाट लेखौँ here therefore angle AOD plus angle BOD के भएछ angle AOB is equal to angle OCA plus what is angle OAC now angle OAC is equal to angle OCA so instead of angle OAC you can write angle OCA plus let us write this one angle OCB plus again what is angle OBC from here angle OBC is equal to angle OCB is that clear now so next or angle AOB is equal to what is angle OCA plus angle OCA twice angle OCA plus what is angle OCB plus angle OCB twice angle OCB so I think I've understood it so let us simplify it now or angle AOB is equal to कति कमन आयो चाहिँ यहाँ अब 2 कमन आयो हैन so 2 within bracket angle OCA plus angle OCB or angle AOB is equal to twice now what is the summation of angle OCA and OCB OCA is this cross one and OCB is this right one if we add these two angles what do we get angle ACB isn't it so twice angle ACB so we have proved it that means we have proved that the angle subtended at the center O of the circle by an arc AKB is equal to twice the angle subtended at the remaining part of the circle subtended by the same arc AKB so we have proved it okay so it is proved so this is very important theorem okay so we can revise it at home so we'll do the next theorem now so now we'll do theorem number 4 so you have to prove that angles in the same segment of a circle are equal now before we prove this theorem let us try to know the meaning of same segment of a circle what do you mean by segment of a circle okay what do you mean by segment of a circle suppose you draw a circle and suppose AB is a chord of the circle AB is a chord of the circle ठीक छ एउटा सर्कल बनियो सर्कलमा एउटा हामीले के बनायो AB chord बनायो यो माथिको भागलाई हामी के भन्छौं it is a part of the circle that is known as the segment of the circle यसलाई भनिन्छ हामी के भन्छौं segment of a circle भनेर भन्छौं ठीक छ अनि तल्लो भाग पनि बन्यो तल्लो भागलाई पनि हामी के भन्छौं यसलाई पनि के भन्छौं हामीले segment of a circle or part of the circle भनेर हामी भन्छौं ठीक छ त एउटा सर्कल बनियो सर्कलमा हामीले के बनायो एउटा कर्ड बनायो हैन त यो माथिको फिगरलाई हामीले यहाँ बाहिरपट्टि निकाल्यौं हैन त AB यो माथिको एउटा सर्कलको भाग भयो यसलाई चाहिँ हामी के भन्छौं सर्कलको एउटा भाग भयो दैट इज द सेगमेन्ट अफ अ सर्कल यो फेरि AB को तल्लो भाग पनि यो तल्लो भागलाई पनि हामी के भन्छौं पार्ट अफ द सर्कल दैट इज आल्सो नोन एज द सेगमेन्ट अफ द सर्कल इज दैट क्लियर दैट मीन्स this is the segment of the circle the same segment of the circle भनेपछि के भयो angles in the same segment of the circle भनेपछि के हो भन्दा फेरि suppose C. C is any point of the circle, right? And you know about the arc of the circle also, AKB, right? So join A and C and join C and B. Join C and B, right? And also you take any point D on the circle, you join D and A and you join D and B. Okay? Now in this case, angle ACB is the angle subtended by the arc AKB, and also angle ADB is the angle subtended by the same arc AKB. And now they are on the same segment of the circle, isn't it? You AB ko mathipati ni cha duita angle. That is angle ACB pani AB ko mathipati, angle ADB pani यो AB को कतापटि छ माथिपटि छ. यसलाई भन्छ angles in the same segment of the circle. अघि नै मैले भने यो AB को जुन चाहिँ माथिल्लो भागमा सर्कल छ यसलाई हामी के भन्छौं segment of a circle भनेर भन्छौं. So both ACB and ADB are on the same segment of the circle. AB को माथिपटि नै छ. ठीक छ? And now we have to prove that angles in the same segment of a circle are equal. That is, angle ACB is the angle made by the arc AKB and angle ADB is the angle made by the same arc AKB, and they are on the same segment of the circle, and you have to prove that these two angles are always equal. So I think you understood the meaning of same segment of a circle. Is that clear? And you have to prove that angles in the same segment of a circle are equal. Okay, now we'll do the theorem. So now let us prove that angles in the same segment of a circle are equal. Okay, so now draw a circle. So we have drawn a circle with the center O. We have drawn a circle with the center O. Okay, and now this is AB is the chord of a circle, right? Now you take any point C on the circle, you join A and C and you join C and B, right? And ACB is the angle subtended by the arc AKB. Now you know the meaning of the arc AKB, right? So now, suppose there is another point D here. Suppose there is another point D there, right, on the circle. You join D and A, also you join D and A, and you join D and B. And you also join D and B. So, angle ACB and angle ADB are the angles on the same segment of the circle, subtended by the same arc AKB, and you have to prove that these two angles are always equal. That means you have to prove that angles in the same segment of a circle are equal. Is that clear? Now let us prove it. Now first of all you have to write down given, right? So what is given here? Angle ACB and angle ADB are the angles on the circle, with the center O, on the circle with the center O. Angle ACB and angle ADB are the angles on the circle with the center O on the same segment, and angle ACB and angle ADB are the angles on the circle with the center O, and they are on the same segment of the circle. They are on the same segment of the circle. That is, you दुईटै angle, you chord AB को माथिपट्टि नै छ. That means they are on the same segment of the circle. ठीक छ? So angle ACB and angle ADB are the angles on the circle with the center O. Right? And they are on the same segment of the circle. Is that clear? And these angles are subtended by the same arc AKB. So therefore, angle ACB and angle ADB are the angles subtended by the same arc AKB. Angle ACB and angle ADB are the angles subtended by the same arc AKB. Now what is to be proved? These two angles, angle ACB and angle ADB, are equal. Now, to prove, what is to be proved? Angle ACB is equal to angle ADB. What is to be proved? Angle ACB is equal to angle ADB. हामीले यो दुईटा एंगल चाहिँ इक्वल छ भनेर प्रमाण गर्नु पर्यो हैन. ल अब हामी यहाँ पनि हामी कन्स्ट्रक्सन गर्छौं. Now construction. अब हामी construction मा के गर्छौं? This is the center O. Let us join O, A and O, B. Right? So here O, A and O, B are joined. हामीले के गर्यौं? यो फिगरमा O र A जोइन गर्यौं अनि O र B पनि जोइन गर्यौं. ठीक छ? त अब यहाँ हामी के देख्छौं भन्दा फेरि angle AOB is the angle at the center O of the circle subtended by the arc AKB. Also, angle ACB is the angle at the remaining part of the circle subtended by the same arc AKB. So what can you write? From the previous theorem, you can write down that angle AOB is equal to twice angle ACB. Just now in theorem 3, we proved that angle subtended at the center O of the circle by an arc is twice the angle subtended at the remaining part of the circle subtended by the same arc AKB. Is that clear? So we will write here. Now proof. Now proof part. We will write down that angle AOB is the angle AOB is the angle at the center O of the circle subtended. Angle AOB is the angle at the center O of the circle subtended by the arc AKB and angle AOB is the angle at the center O of the circle subtended by the arc AKB and angle ACB. And what is angle ACB here? Angle ACB is the angle ACB is the angle at the remaining part of the circle subtended by the same arc AKB, subtended by the same arc AKB. हामीले यहाँ के लेख्यौं भन्दाखेरि angle AOB is the angle subtended at the center O of the circle by the arc AKB, and also angle ACB is the angle at the remaining part of the circle subtended by the same arc AKB. That means from theorem 3, what can we write? Directly we can write down that this angle AOB is equal to twice angle ACB. So therefore angle AOB is equal to twice angle ACB. We can write down this relation from the previous theorem. That is, we have just done theorem 3. That is, angle AOB is equal to twice angle ACB. Now similarly, angle AOB is the angle at the center O of the circle subtended by the arc AKB, and also angle ADB is the angle at the remaining part of the circle subtended by the same arc AKB. So here also from previous theorem number 3, what can I write? Angle AOB is equal to twice angle ADB. Right? So let us write it here again. Again, angle AOB is the angle at the center O of the circle subtended by the arc AKB, and angle ADB. And angle ADB is the angle at the remaining part of the circle subtended by the same arc AKB, subtended by the same arc AKB. That is, again, angle AOB is the angle at the center O of the circle subtended by the arc AKB, and angle ADB is the angle at the remaining part of the circle subtended by the same arc AKB. So therefore, what can we write here? Again, from previous theorem number 3, we can write down that angle AOB is equal to twice angle ADB. That is, angle AOB is equal to twice angle ADB. Is that clear? So let us mark it number 1 and this as number 2. So from 1 and 2, what can we write? So from 1 and 2, these left hand sides are equal, right hand sides must be equal, right? So let us write. So therefore from 1 and 2, now since these left hand sides are equal, isn't it? This is also angle AOB, this is also angle AOB. If left hand sides are equal, right hand sides must be equal. So from 1 and 2, what can we write? Twice angle ACB is equal to twice angle ADB. Twice angle ADB. So here 2 gets cancels. So what can we write? Therefore, angle ACB is equal to angle ADB. That means angle ACB is equal to angle ADB. So what conclusion can you make from here? That is, angles in the same segment of a circle are equal. That is proved. So just now we proved that angles in the same segment of a circle are equal. Hence, angles in the same segment, of a circle are equal. So it is proved. So I think you have understood it. So you have to write down all the answers in your copy and you have to learn it. Okay, so we'll do the next theorem now. Now we will do theorem number 5. Prove that angle in a semicircle is a right angle. So what is meant by angle in a semicircle? यो याद गर्नुपर्छ पहिला सबभन्दा पहिले यो थ्योरम गर्न अगाडि angle in a semicircle भनेको के हो? Semicircle भनेको half of the circle. बुझ्यो? Semicircle भनेको half of the circle. जस्तै तिमीले सर्कलमा एउटा डायमिटर बनाउँछौ, त्यो डायमिटरले चाहिँ त्यो सर्कललाई 2 equal parts मा डिवाइड गर्छ. That is दुईटा सेमी सर्कलमा त्यसलाई डिवाइड गरिदिन्छ. बुझ्नु छैन? जस्तै let us draw a circle now. This is a circle with the center what? With the center O. Let us draw a diameter of the circle. This AB is a diameter of the circle. Okay? That is, this diameter AB will divide the circle into 2 equal parts. One is above AB and one is below AB. So, यो जुन चाहिँ AB को माथिबाट जुन चाहिँ सर्कल छ त्यसलाई पनि सेमी सर्कल भनेर हामी भन्छौं. अनि AB को जुन चाहिँ तल्लो भाग छ त्यसलाई पनि हामी के भन्छौं? सेमी सर्कल. यो दुईटाको एरिया चाहिँ के हुन्छ? इक्वल हुन्छ. That means this diameter AB will divide the circle into 2 equal parts. Is that clear? So now, what do you mean by angle in a semicircle? Our angle in a semicircle भनेको के हो? Let us take the segment above the diameter AB. Let us take the segment of the circle above the diameter AB, right? You take any point C on the circle, which is above AB, right? Now join A and C. लो अब हामी A र C join गर्छौं. A र C join गर्यो. अनि यो C र B पनि join भयो. भनेपछि यो जुन चाहिँ एंगल बनायो, यो एंगल चाहिँ एउटा सेमी सर्कलमा भयो नि त, हैन? So your angle ACB is drawn in the semicircle. That's why this is known as angle ACB is the angle in the semicircle. So यो जुन चाहिँ हामीले जुन चाहिँ अहिले भर्खर जुन चाहिँ एउटा एंगल ACB बनाउँदै छौं, त्यो चाहिँ हामीले सेमिसर्कलमा बनायौं नि त. त्यसलाई भनिन्छ angle in the semicircle. And you have to prove that the angle in the semicircle is a right angle. तिमीले के प्रुभ गर्नु छ? यो एंगल ACB चाहिँ एउटा right angle हो भनेर प्रुभ गर्नुपर्छ. That means you have to prove that angle ACB is equal to 90 degree. Is that clear now? So let us prove it. Now we have understood the meaning of semicircle and angle in the semicircle. Okay? Now let us prove it. Given a circle with the center O, a circle with the center O is given. A circle with the center O is given. And angle ACB is the angle in the semicircle. So angle ACB is the angle in the semicircle. Okay? Now to prove, what is to be proved here? You have to prove that the angle in a semicircle is a right angle. Right angle by 90 degree. That is, you have to prove that angle ACB is equal to 90 degree. Right? Now let us do proof. Here the construction is not needed. Or फाल्टो construction or हामीले यहाँ गर्नु पर्दैन. बुझ्नु छैन? So now how can you prove it? With the help of theorem 3 we can prove it. Okay? So now let us take a point K out here. That means this AKB is an arc of a circle, right? This AKB is an arc of a circle, right? So in this case also, let us mark it O out here. So this is an angle AOB. This is known as the straight angle, isn't it? Angle AOB. This angle AOB is known as the straight angle. AOB is straight line. So this angle AOB is known as the straight angle. Now angle AOB is the angle at the center O of the circle subtended by the arc AKB. And also angle ACB is the angle at the remaining part of the circle subtended by the same arc AKB. So from previous theorem we can write down that this angle AOB is equal to twice angle ACB. Is that clear now? So here also we are using the previous theorem to prove this theorem number 5. That is, angle in a semicircle is a right angle. Is that clear now? So let us do the proof part. Now angle AOB is the angle at the center O of the circle subtended by the arc AKB. So angle AOB is the angle at the center O of the circle subtended by the arc AKB. So एउटा कुरा याद गर्नु तिमीले यहाँ म जुन चाहिँ लेख्दैछु यो सबै लेख्नुपर्छ तिमीले खातामा. पछि prove that angle in a semicircle is a right angle भनेर आयो भने यो सब लेख्नुपर्छ तिमीले. बुझ्यौ? Theorem 1, Theorem 2, त्यहाँदेखि हामीले application theorem गर्यौं. Then we did Theorem 3, Theorem 4 and Theorem 5. यो सबै नै तिमीले खातामा कपी गर्नुपर्छ. ठीक छ? अनि पछि एक्जाममा यस्तो खाले क्वेशन आयो यो सब लेख्नुपर्छ with figure. मैले अस्ति नै भने if all these portions are written but without figure, no marks will be given. No credit is given out there, right? So you have to draw the figure. Figure बनाएपछि मात्र तिमीले marks पाउँछ. So without figure, you won't get any marks. Okay? So यो पनि तिमीले सबैले सार्दै जाने ल. So angle AOB is the angle at the center O of the circle subtended by the arc AKB. And also angle ACB is the angle at the remaining part of the circle angle ACB is the angle at the remaining part of the circle subtended by the same arc AKB. Full stop. Right? Also, angle ACB is the angle at the remaining part of the circle subtended by the same arc AKB. So what can you write now? Therefore, here also we can write down that therefore we can write here angle AOB is equal to twice angle ACB. Since angle AOB is the angle at the center O of the circle subtended by the arc AKB, and also ACB is the angle subtended at the remaining part of the circle by the same arc AKB. So we can write down that angle AOB is equal to twice angle ACB. But angle AOB is a straight angle. This is known as the straight angle. Since AOB is a straight line, isn't it? So what is angle AOB? It is 180 degree. Therefore, angle AOB is equal to 180 degree. Okay? So now again write down this part. Angle AOB is equal to twice. This is twice angle ACB, right? So angle AOB is equal to twice angle ACB. Okay? What is angle AOB? It is 180 degree is equal to twice angle ACB, or 180 degree divided by 2. 2 is taken to the left hand side. It goes to the denominator. So which is equal to angle ACB, right? Or now this is your 90 degree, which is equal to angle ACB, or angle ACB is equal to 90 degree. That is, angle ACB is the angle in the semicircle, isn't it? And we have proved that angle ACB is equal to 90 degree. Hence, angle in the semicircle is a right angle. Hence, angle in the semicircle, is a right angle. 90 degree but make your right angle. So it is proved. So I think you have understood it. So you revise all the theorem that we did today, that is theorem 3, theorem 4 and theorem 5. Okay, so this much is for today. So in the next class we will do more theorems, right? So this much is for today.